Welcome to EduRev.
Hello children, welcome to EduRev classes. Let me introduce myself. I am Sarvani Nandipati, a graduate from NIT Calicut who has 3+ years of teaching experience for both board and competitive exams. In this video, we'll be continuing the topic relations and functions. What we'll be covering are composite functions, inverse of a function, and few NCERT problems. Let's start. Composite function. Let f is from a to b and g is from b to c be two functions. Then the composite of f and g is denoted by g circle f. Is defined as the function g circle f is from a to c given by g circle f of x is equal to g of f of x for all x belongs to a. Let's try to understand this definition with an example. Now let us say there are three sets A, B and C. X belongs to set A. It is connected to an element in B under the function f. So what will be the element it got connected? Simply f of x. Similarly, this same element f of x got connected to another element in set C under the function g. So what will that element become? G of f of x. Why? If the element is y and it is connected under the function g, you write it as g of y. Now the element is f of x, so we'll write simply it as g of f of x. If you want to find the relation between x and g of f of x, how they are connected, that is called g circle f. So for this g circle f, what is your domain? That will be A or the first set, and what will be the codomain? That is here C at the second set. So first set domain will be the domain and the second set codomain will be the codomain of the G circle F. I hope it is clear. And few things you have to remember. In general, G circle F is not equal to F circle G. That is, it is not commutative. And if F is from X to Y and G is from Y to Z and H is from Z to S are functions, then H circle G circle F is equal to H circle G circle F. That is associative. So they are telling this function is not commutative in general, but it is associative. And one more thing you can remember is if G circle F is 1, 1, then F is 1, 1. And if G circle F is onto, then G is onto. The proofs were there in the summary section. You can check that. I hope it is clear and I'm moving on to the next slide. Let's try to look at an example. Let f is from the elements 2, 3, 4, 5 to set which containing the elements 3, 4, 5, 9 and g is from the set containing 3, 4, 5, 9 to the elements of the set containing 7, 11 and 15. Be functions defined as f of 2 is equal to 3, f of 3 is equal to 4, f of 4 is equal to f of 5 is equal to 5 and g of 3 is equal to g of 4 is equal to 7 and g of 5 is equal to g of 9 is equal to 11. In this case, find G circle F. When you want to find the G circle F, check these sets. They should be actually seen. Okay. The codomain of the first set and the domain of the second set. Now, what was given? F of 2 is equal, f of 2 values, f of 3, f of 4, f of 5 values I have noted down and g of 3, g of 4, g of 5 and g of 9 values also I have noted down. G circle F. I will find for all the elements 2, 3, 4, 5. What is G circle F of 2? As per the definition, it is equal to G of F of 2. But what did they give F of 2 value as? 3. So I will replace F of 2 with 3. So it is G of 3. What is the value of G of 3? They have mentioned it is 7. So the value is 7. So what is G circle F of 2? That is 7. And G circle F of 3? G of F of 3. What is f of 3 value? 4. So I am replacing f of 3 with 4. What is g of 4? The value was simply 7. What is G circle f of 4? G of f of 4. What is f of 4 value? They have told it is 5. So I am replacing f of 4 with 5. So what is G of 5? G of 5 value was given as 11. So this value is 11. Similarly, G circle f of 5. that is g of f of phi. What is g of f of phi value? Phi. So I am simply writing the value as phi. So what is g of phi? 11. So the value is 11. I hope it is clear how to find G circle F. We'll move on to another example. From exercise 1.3, third question. Find G circle F and F circle G if f of x is equal to mod x and g of x is equal to mod of 5x minus 2. What is the information I have written? I am finding G circle F. What is G circle F of x? G of f of x. That is g of mod x. What is g of mod x? Mod of 5 mod x minus 2. See, g of y means what will you write? Mod of 5y minus 2. So whatever is there inside the g, that you will be writing in the place of x. So that is mod of 5 mod x minus 2. That will be your answer for G circle f of x. Now we'll find f circle g. What will be f circle g of x? F of g of x. What is g of x value? Mod of 5x minus 2. Now what will be f of mod 5x minus 2? Wherever x is there, replace with the value written here. That means mod of mod 5x minus 2. Mod itself gives you a positive value. So there is no need of writing mod twice. Because positive value, if you put under mod, anyways it will give you the same value. So I am writing it as mod of 5x minus 2. See, G circle F is giving me value as mod of 5 mod x minus 2. Whereas F circle G of x is giving me the value as mod 5x minus 2. And these both are not actually same. So I can conclude in general G circle F is not equals to F circle G, or the composite functions are not commutative. I hope it is clear. I am moving on to the next slide. Show that f is from b to a is defined by f of x is equal to 3x plus 4 by 5x minus 7, and g is from a to b is defined by g of x is equal to 7x plus 4 by 5x minus 3. Then f circle g is equal to ia and g circle f is equal to ib, where a is equal to all real numbers excluding 3 by 5 and b is all real numbers excluding 7 by 5, and ia of x is equal to x for all x belongs to b are called the identity functions on the sets a and b respectively. So what they are trying to tell is they have given us two functions and they were asking us f circle g is equal to I of a and g circle f is equal to I of b, as they are asking us to prove both of them as identity functions. And why they are excluding this from the set a's and b's? See, if the b value has 7 by 5, the function will not be defined because 5 into 7 by 5 minus 7 is 0. Similarly, for the g function, if the x value is 3 by 5, the function will not be defined. That's why they are excluding 3 by 5 from the set A. Always check those terms, okay? Now, I am checking for G circle F is equal to IB. G circle f of x, how can I write g of f of x? What is f of x value? I am replacing f of x with the value that I know. That is g of 3x plus 4 by 5x minus 7. But what is g? 7x plus 4 by 5x minus 3. So, g of 3x plus 4 by 5x minus 7 means wherever x is there, you have to replace x with this value. So, what will happen? 7 into 3x plus 4 by 5x minus 7 plus 4 by 5 into, here you have to write it as 3x plus 4 by 5x minus 7 minus 3. If I take LCM, what will happen? 7 into 3x plus 4 into 5x minus 7 by 5x minus 7 by 5 into 3x plus 4 minus 3 into 5x minus 7 by 5x minus 7. And I have simplified those values. 7 3s 21x, 7 4s 28, and 5x minus 7 into 4 means 4 5s 20x, and minus 7 into 4 is minus 28. And here 5 into 3x plus 4 means 5 3s 15x, 5 into 3x is 15x and 5 into 4 is 20. Minus 3 into 5x minus 7 is minus 3 into 5x is minus 15x and minus 3 into minus 7 is plus 21. And 5x minus 7 gets cancelled in the numerator and the denominator part. And what is left out? 21x plus 20x is 41x, 28 gets cancelled. Here 15x minus 15x gets cancelled and 20 plus 21 is 41. So 41x by 41 is simply x. So you have started with x and you are ending up with the output also x. That means G circle f is an identity function under B. Why B? Because the function is from B to B. See, f is from B to A and G is from A to B means G circle f will be from B to B. That is where they are writing it as IB, identity function under the set B. That's what it means. Now we'll go to the second part, f circle G. What will be that? F circle G of x is f of G of x. I am replacing the G of x value with its original value, that is f of 7x plus 4 by 5x minus 3. I have to, what is f of 7x plus 4 by 5x minus 3? Wherever x is there, I have to replace that with 7x plus 4 by 5x minus 3 in the equation. So what will happen? 3 into 7x plus 4 by 5x minus 3 plus 4 by 5 into 7x plus 4 by 5x minus 3 minus 7. Simply wherever x is there in the equation, I am replacing it with these terms. If I simplify further, after taking LCM, what will be that? 3 into 7x plus 4 into 5x minus 3 by 5 into 7x plus 4 minus 7 into 5x minus 3. The 5x minus 3 terms get cancelled in the numerator and the denominator. So 7 3 is 21x plus 3 4 is 12 plus 4 into 5x is 20 plus 4 into minus 3 is minus 12. And here 5 into 7x is 35 plus 5 into 4 is 20 minus 7 into 5x is minus 35 and minus 7 into minus 3 is plus 21. So here plus 12 minus 12 gets cancelled. 21x plus 20x is 41x. And here in the denominator 35x minus 35x gets cancelled and 20 plus 21 is 41. So 41x by 41 is simply x. You have started with x and after applying this function f circle G, you are ending up with x. But x is from the set A. Why? G is from A to B and f is from B to A means f circle G will be simply from A to A. And the function is an identity function under A. So that means I can conclude f circle G is equal to I of A or IA or identity function. I hope it is clear. I'm moving on to the next slide. Inverse of a function. A function f is from x to y is defined to be invertible if there exists a function g is from y to x such that g of f is equal to ix and f of g is equal to iy. So when they say function is invertible, if f is from x to y, the function should be from the reverse of it. That is, the function should be from y to x and it should satisfy the condition g circle f should be equal to ix and f circle g should be equal to iy. And the g is called the inverse of x and it is denoted by f inverse. And one can say the function is invertible if and only if it is both 1, 1 and onto, or it is bisective. Even the converse is true. That means if the function is 1, 1 and onto or bisective, then only inverse exists. Note, there is another thing you have to remember. If f is from x to y and g is from y to z, if these both are invertible functions, then g circle f is also invertible. The composite function is also invertible and its value is g circle f whole inverse can be written as f inverse circle g inverse. The proof you can check at the note section. I am moving on to an example. Consider f is from r plus the positive integers to close interval 4 to infinity given by f of x is equal to x square plus 4. Show that the function f is invertible with the inverse of f given by f inverse of y is equal to root of y minus 4, where positive real numbers is the set, R plus is the set of all non-negative real numbers. First, they are asking you to prove it is invertible. That means you have to prove it is both 1, 1 and onto, and then you have to find inverse of it. So how do you check the given function is 1, 1? If f of x1 is equal to f of x2, x1 should be equal to x2. So I am assuming that x1, x2 belongs to the positive real numbers and f of x1 is equal to f of x2. So what can I write? x1 square plus 4 should be equal to x2 square plus 4. Then x1 square is equal to x2 square. So what can I conclude? x1 is equal to plus or minus x2. Can I take x1 value is equal to minus x2? No. Why? Because both x1 x2 belongs to only positive real numbers. So one value cannot be the negative value of the other. So I am coming up to the conclusion that x1 is equal to x2. So if f of x1 is equal to f of x2, and if f of x1 is equal to f of x2 implies x1 is equal to x2, the function is 1, 1. Now I'll check for onto. So the condition is same. How do you check for onto? I'll take y is equal to f of x is equal to x square plus 4. I'll check for which values of x, y is not defined. So y is equal to x square plus 4. X square is nothing but y minus 4. X is equal to plus or minus root of y minus 4. But x is not equal to minus root of y minus 4. Why? The value under the square root will always be positive and minus of a positive value will be negative. But x belongs to all real numbers, all positive real numbers. So I am removing this option. So x is equal to root of y minus 4. But you know that all the values under the root should be positive. That means y minus 4 should be greater than or equal to 0. Y should be greater than or equal to 4. If you take any value of y which is less than 4, the function will not be defined. Say if I take y value as 3, root of minus 1, that is I, you are not even getting a real number. But x belongs to only positive real numbers. So if x is supposed to be defined, y value should be greater than or equal to 4. But what was the codomain given? Yeah, all the values from 4 to infinity, where 4 has a closed interval, which is exactly matching with what we have got. So given codomain, all the x values satisfies the condition. Now we have to check for f of x is equal to y. F of x is equal to x square plus 4. What is x? We have got root of y minus 4. I am replacing f of x with that value. So f of root of y minus 4 is equal to root of y minus 4 whole square plus 4. Square and root gets cancelled. So y minus 4 plus 4. What will be the value? Y. So now I can conclude for every value of y which belongs to the interval, closed interval 4 to infinity, there exists an element x which belongs to positive real numbers such that f of x is equal to y. Hence I can conclude the given function is onto. So if it is 1, 1 and onto, it will be bisective. If the function is bisective, then only it will be invertible. So we were able to do that. Now there is a part we have to find inverse of x. What is inverse of x? F inverse of y. What is f inverse of y? X value, that is simply root of y minus 4. So this will be called the inverse of x. I hope it is clear, and I am moving on to the next slide. Let f is from all real numbers excluding 4 by 3 to real numbers be a function defined as f of x is equal to 4x by 3x plus 4. The inverse of f is the map G, and it is from range of f to all the real numbers excluding 4 by 3 is given by. So in this question, they have told us G is the inverse of f. You need not check whether it is 1, 1 or onto. You are only supposed to find the value of it. How do you find that? You will take y is equal to f of x, and then you will write y as the whatever is the function value of x. You will write that value in terms of completely x. So whatever is the output you are getting, that is called the inverse. So f of x is equal to 4x by 3x plus 4. I am taking f of x is equal to y. So y is simply 4x by 3x plus 4. I am taking 3x plus 4 to the other side. Y into 3x plus 4 is equal to 4x. So 3xy plus 4y is equal to 4x. I'm taking plus 4x to the other side, so it's minus 4x, and 4y to the other side, so it's minus 4y. If I take x common, what will happen? 3y minus 4, x into 3y minus 4 is equal to minus 4y. So what will be x? 4y by 4 minus 3y. They have multiplied with the minus sign for this whole equation. So 4y is x into 4 minus 3y will be 4y, and x is equal to 4y by 4 minus 3y. So inverse of f is 4y by 4 minus 3y, and g of y can be written as 4y by 4 minus 3y. Sometimes they'll give it in terms of x. What will be g of x? Simply 4x by 4 minus 3x. That's it. So which option gives me that answer? 4y by 4 minus 3y? Option B. So my answer is option B. I hope it is clear. I'm moving on to the next slide. If f is from R to R be given by f of x is equal to 3 minus x cube whole to the power 1 by 3, then f circle f of x is equal to, they have given the options. Now what is our task? Is to find f circle f of x, right? What is that? Simply f of x. So I have to replace this f of x with its value. So f of 3 minus x cube whole to the power 1 by 3, right? I have to find that. What will be that? In the place of x, what should I write? 3 minus x cube whole to the power 1 by 3. So look at carefully. From this step to the next step, what will be the value? 3 minus, in the place of x, I am writing 3 minus x cube whole to the power 1 by 3. And x cube, so I have a cube here to the power 1 by 3. Check clearly. See what was written here. Instead of x, I am writing this value 3 minus x cube whole to the power 1 by 3. See, 3 minus x cube whole to the power 1 by 3 is the function. In the place of x, what am I doing is, I am writing it as 3 minus x cube whole to the power 1 by 3. So this 1 by 3 and this 3 gets cancelled. So what will happen? 3 minus x cube whole to the power 1 by 3. So if I bring minus inside, 3 minus 3 plus x cube. 3 gets cancelled, so it's simply x cube whole to the power 1 by 3. So what is the value? X. So what can I infer? Actually, f circle f of x is an identity function and the value is x. So the answer is option C. I hope it is clear, and when you are doing these functions, don't get confused. Simply whatever is there inside the f, replace the x term on the other side with that value. Then do simplification further, you will get answer. I hope it is clear. I am moving on to the next slide. With this, I will be ending today's video session here. In case if you want to look at the summary, you can check the notes section. And there were almost 10,000 plus questions for practice across all the subjects. All those were prepared by NCERT experts. So you can give a try. And after that, you will also get a national wide ranking so that you can know well about where do you stand and where do you want to improve. In case if you haven't taken the EduRev Infinity subscription, do it today. Thanks for staying tuned. All the best.